close your eyes and feel this moment. Right now, as you breathe in, this second is happening. And now it's gone. Another breath, another moment flowing past like water in a gentle stream. You have lived your entire life in this river of time. Every morning you wake up, and yesterday has become a memory. Every night you fall asleep, and tomorrow waits just beyond your dreams. The river carries you forward, always forward, never back. But tonight, we're going to ask a question that might surprise you. What if this river could flow the other way? Think about the water that runs past your house after a summer rain. It rushes down the street, carrying leaves and small stones toward the storm drain. You've never seen that water flow backward up the hill. It would seem impossible, wouldn't it? Like watching a movie played in reverse. Yet scientists around the world are discovering that time might not be as simple as we thought. The rules that govern our universe, written in the language of mathematics and physics, contain a beautiful secret. They suggest that time could flow backward just as easily as it flows forward. Imagine standing by a real river on a calm evening. The water moves past your feet, cool and steady. Each drop that passes will never return to this exact spot. Or will it? In the world of the very small, in the realm of atoms and particles, scientists have found something remarkable. The laws of physics work just as well when time runs backward. Your body is made of billions of tiny particles. They dance and spin inside you right now, following rules that care nothing about yesterday or tomorrow. To these microscopic dancers, the future and the past look exactly the same. They could waltz backward through time as gracefully as they move forward. This discovery began over a century ago. Scientists studying heat and energy noticed something curious. When they wrote down the equations that describe how things move and change, something strange appeared. Time showed up in these equations as just another direction, like left or right, up or down. Picture yourself walking down a path through a peaceful forest. You can walk forward toward the setting sun. You can also turn around and walk back toward where you came from. The path doesn't care which direction you choose. To the path, both directions are equally natural. The equations that describe our universe suggest that time might be like that forest path. We experience it flowing in one direction, from past to future. But the mathematical rules that govern everything around you don't prefer one direction over the other. So why do we only experience time flowing forward? Why do we remember yesterday, but not tomorrow? Why do flowers bloom and then fade, never the other way around? These questions have puzzled the greatest minds in science. They've led to discoveries that sound like magic, but are grounded in careful observation and experiment. Scientists have found that while the fundamental laws of physics don't care about time's direction, something else creates the arrow of time we experience. Think about your morning coffee. You pour hot coffee into a cold cup. The heat spreads from the coffee into the cup, warming it. You've never seen the opposite happen. You've never watched a warm cup suddenly become cold while making the coffee hotter. But why not? The answer lies in a concept that scientists call entropy. It's a word that describes how energy spreads out and becomes less organized. Like sugar dissolving in water, energy always spreads from places where it's concentrated to places where it's more scattered. Your warm coffee has concentrated heat energy. The cool air around it has less. Heat flows from your coffee to the air, making the coffee cooler and the air slightly warmer. This spreading of energy creates the arrow of time you experience. It's like a gentle current in the river, nudging everything in one direction. But here's where the story becomes truly fascinating. Scientists have discovered that this spreading isn't absolute. In very small systems, with just a few particles, they've observed time's arrow wobbling. They've seen tiny amounts of energy flowing backward, heat moving from cold to hot, and order appearing from chaos. These discoveries happen in laboratories where scientists can control every particle, every vibration, every tiny interaction. They've learned to make time hiccup, to create small pockets where the river of moments flows backward for just an instant. In your own body, similar miracles happen every second. Your cells perform countless chemical reactions that seem to defy time's forward flow. They build complex structures from simple parts, creating order from chaos. Life itself is a gentle rebellion against time's arrow, constantly swimming upstream in the river of entropy. As you rest here tonight, feel the quiet mystery surrounding you. The atoms in your body remember the cores of ancient stars. The energy flowing through your cells has been recycling through the universe for billions of years. You are part of a cosmic river that might be far more flexible than it appears. Scientists are still exploring these deep waters. They're learning that time might have layers and currents we haven't discovered yet. Some researchers believe that consciousness itself might play a role in creating time's direction. Others think that the universe might contain regions where time flows differently or even backward. The river that carries you forward through life might not be as simple as it seems. Beneath its surface, currents of possibility flow in all directions. The future reaches back to influence the past. The past holds seeds of many possible tomorrows. Tonight, as you prepare to sleep, you stand at the edge of this vast mystery. The equations that describe reality whisper of time's hidden flexibility, of moments that could flow backward like gentle waves returning to shore. But to understand these whispers, we must first listen to the heartbeat of reality itself. Place your hand gently on your chest. Feel that steady rhythm beneath your palm. Your heart beats about once every second, marking time like a faithful drum. But this is just one timekeeper among countless others hidden throughout your body and the world around you. Deep inside every cell of your being, smaller clocks tick away. Molecules vibrate. Electrons orbit. Chemical reactions pulse in perfect timing. You are not just living in time. You are made of time itself, constructed from billions of tiny metronomes keeping the beat of existence. Scientists call these natural timekeepers oscillators. Think of a grandfather clock in a quiet hallway, its pendulum swinging back and forth with steady precision. Now imagine that same regularity exists everywhere. In the spin of atoms, in the vibration of crystal structures, in the dance of light itself. The most precise clock humans have ever built doesn't tick like the one on your wall. Instead, it listens to the vibration of atoms. Deep inside a cesium atom, electrons jump between energy levels billions of times per second. Each jump happens with such perfect regularity that scientists use it to define what we mean by time itself. 1 second, officially, equals exactly 9,192,631,770 vibrations of a cesium atom. This number isn't random. It represents the universe's own heartbeat, measured with exquisite precision. Your morning alarm, your favorite song, the timing of traffic lights, all depend on this atomic rhythm discovered by patient scientists. But here's something beautiful. These atomic clocks don't just measure time. They help us understand something profound about reality itself. Time isn't separate from the physical world. It emerges from the very structure of matter and energy around you. Picture a music box with its tiny dancing figures. Wind the spring, and the dancers begin their waltz. The music plays. The figures spin. But what makes the music possible? It's the regular unwinding of the spring, the steady rotation of the cylinder, the precise spacing of the metal pins that pluck the comb. The universe works like an impossibly complex music box. Every particle contains springs and wheels and dancing figures. Every interaction between particles plays a note in reality's grand symphony. And just like the music box, the whole performance depends on precise timing. Einstein discovered something remarkable about this cosmic clockwork. He found that time isn't the same everywhere. If you could ride on a beam of light, your personal clock would seem to stop completely compared to someone watching from Earth. If you stood near a massive star, your watch would run slower than one sitting on your nightstand. This means that the universe doesn't have just one master clock. Instead, every point in space and time has its own local rhythm. Your bedroom, the moon, distant galaxies, each keeps time slightly differently. Yet somehow, this cosmic orchestra stays in harmony. The reason lies in the deepest laws of physics. These laws act like a conductor's baton, coordinating the performance across all of space and time. They ensure that cause follows effect, that energy flows in predictable ways, that the dance of particles remains synchronized across the cosmos. But what creates these laws themselves? Why does the universe tick in such orderly fashion? Scientists believe the answer lies in something called symmetry. Just as a snowflake's 6 sides mirror each other perfectly, the laws of physics show perfect balance and proportion. These symmetries run deeper than anything you can see or touch. They exist in the mathematical relationships between space and time, between matter and energy, between the forces that hold atoms together and push galaxies apart. When scientists study these hidden symmetries, they find something surprising. Many of these fundamental symmetries work exactly the same whether time flows forward or backward. It's like discovering that a beautiful piece of music sounds just as harmonious when played in reverse. The melody might change, but the underlying mathematical relationships remain perfect. This discovery shook the scientific world. If the deepest laws of physics don't care about time's direction, then what creates the forward flow of time that you experience? What makes causes come before effects? What prevents you from remembering tomorrow? The answer involves a delicate balance between order and chaos. Imagine a perfectly arranged deck of cards. Now shuffle it once. The cards become slightly mixed up. Shuffle again, and they become more scrambled. Each shuffle adds randomness, moving the deck further from its original perfect order. In physics, this mixing process has a name: entropy. It's the universe's tendency toward disorder, like books falling off a shelf or coffee cooling in your cup. Entropy creates time's arrow by making some arrangements of matter and energy more likely than others. But here's the fascinating part. In the realm of the very small, entropy sometimes flows backward. Scientists have observed tiny systems where energy flows from cold to hot, where disorder spontaneously becomes order, where effect seems to precede cause. These observations don't break the laws of physics. Instead, they reveal that those laws are far more flexible than we imagined. They show that the clockwork heart of reality beats with a rhythm more complex than any music we've composed. Your own body demonstrates this complexity every moment. Your cells build proteins from simple chemicals, creating order from chaos. Your brain forms memories from scattered neural signals. Your heart coordinates billions of cellular clocks to maintain its steady rhythm. Life itself is a temporary victory over entropy, a brief eddy in time's river where complexity grows instead of fades. Every breath you take, every thought you think, represents the universe organizing itself in ways that seem to defy time's forward march. As you rest tonight, feel yourself connected to this vast cosmic clockwork. Your heartbeat synchronizes with rhythms that span from the smallest atom to the largest galaxy. You are part of a universe that keeps time through the motion of every particle, the vibration of every wave, the dance of every force. The precision is breathtaking. The harmony is perfect. Yet beneath this orderly surface, scientists are discovering that time's clockwork allows for something unexpected. In the quantum world, where the smallest parts of reality play by different rules, the steady tick of universal time begins to stutter and change in ways that challenge everything we thought we knew about cause and effect. Imagine looking into a mirror that shows not your reflection, but a glimpse of tomorrow. This sounds like fantasy, yet in the world of the very small, scientists have discovered something almost as strange. Particles can behave as if they know what's coming next, responding to future events before those events happen. You're made of trillions of these tiny rebels. Every atom in your body contains electrons that dance to quantum rhythms. These microscopic performers follow rules so different from your everyday experience that they seem to come from another universe entirely. In your familiar world, causes always come before effects. You flip a light switch, and then the bulb glows. You drop a stone, and then it falls. But in the quantum world, this orderly sequence becomes a graceful dance where partners sometimes switch roles. Picture a pond on a perfectly still morning. You toss a pebble into the center, and ripples spread outward in perfect circles. Now, imagine those ripples somehow reaching the shore before you throw the pebble. This impossible scene captures something real about how particles behave at the smallest scales. Scientists discovered this strangeness while studying light. They found that a single particle of light, called a photon, could travel along multiple paths at the same time. It's as if you could walk to school by taking every possible route simultaneously, only choosing one path when you finally arrive. This quantum behavior has a beautiful name: superposition. Like a musical chord that contains many notes at once, a quantum particle exists in many states simultaneously until something observes it or measures it. Only then does it choose a single reality from all its possibilities. But here's where time becomes truly mysterious. When scientists measure a quantum particle, that measurement seems to reach backward through time, determining which path the particle took even before the measurement happened. It's as if your decision to look in the mirror somehow influenced what the mirror was going to show you. Experiments have proven this again and again. Researchers can set up a system where they decide how to measure a particle after it has already passed through their equipment. Somehow, the particle behaves as if it knew about the measurement that hadn't been chosen yet. Think about a butterfly landing on a flower. In your world, the butterfly sees the flower, flies toward it, and then lands. Cause and effect. But in the quantum world, it's as if the butterfly's landing somehow influences where the flower decides to bloom, even if the flower grew yesterday and the butterfly lands tomorrow. This doesn't mean that time flows backward in the quantum realm. Instead, it suggests that the neat separation between past and future that you experience might be an illusion created by your size and perspective. At the smallest scales, past and future might be partners in a dance you can barely imagine. Your brain contains billions of neurons, each one a complex chemical system that might follow quantum rules. Some scientists wonder if your thoughts themselves might involve quantum processes, connecting your consciousness to this strange realm where time behaves differently. When you remember something, are you reaching backward through time to retrieve information? When you imagine the future, are you somehow touching possibilities that already exist in quantum form? These questions push at the boundaries of what science understands about minds, memory, and time. Quantum particles don't just blur the line between past and future. They also seem to communicate across vast distances instantly, sharing information faster than light could travel between them. Einstein called this spooky action at a distance because it troubled him so deeply. Yet experiments have shown that when two particles become entangled, measuring one instantly affects the other, no matter how far apart they are. It's as if they remain connected by invisible threads that care nothing for the speed limit of the universe. This quantum connection might extend through time as well as space. Some particles seem to be entangled not just with distant partners, but with their own future and past states. They exist in a web of relationships that spans both time and space, creating a reality far richer than it appears on the surface. You experience hints of this quantum strangeness in your daily life. Sometimes you think of a friend just before they call. Sometimes you dream of events that later come true. These moments might be glimpses into the deeper quantum nature of reality, where your consciousness touches the web of connections that unite all things across space and time. The mathematics that describe quantum behavior are perfectly time-reversible. Every equation works just as well whether time flows forward or backward. This means that at the deepest level of reality, the universe doesn't prefer one direction of time over another. So why do you experience time flowing in only one direction? Why do quantum effects seem to disappear when you look at larger objects like trees and cars and people? The answer involves the delicate relationship between the quantum world and the classical world you inhabit. As quantum particles interact with their environment, they lose their quantum properties through a process scientists call decoherence. It's like a symphony where individual instruments slowly fall out of tune until only a simple melody remains. But decoherence doesn't destroy quantum effects completely. It hides them, like stars that disappear in daylight but continue shining above the blue sky. In special laboratory conditions, scientists can slow down or even reverse decoherence, allowing quantum strangeness to persist longer. Some researchers dream of creating quantum computers that maintain superposition and entanglement long enough to perform calculations impossible for regular computers. These machines might give us new ways to explore the relationship between quantum mechanics and time. Others investigate whether biological systems like your brain have evolved ways to protect quantum processes from decoherence. Perhaps life itself has learned to surf the quantum waves, using their strange properties to create consciousness, memory, and perception. As you rest tonight, imagine the quantum dance happening inside every atom of your body. Electrons spin in superposition. Photons travel along multiple paths. Particles remain entangled across impossible distances. You are not separate from this quantum realm. You're made of it. The boundary between your classical experience and the quantum reality beneath it is not a wall, but a gentle transition, like the place where a river meets the sea. Sometimes, quantum waves wash up into your conscious experience, bringing hints of the deeper mystery. In the quantum mirror of reality, past and future reflect each other in ways that challenge every assumption about cause and effect. Time becomes not a river flowing in one direction, but an ocean with currents moving in all directions at once. Yet even in this strange quantum ocean, something creates the arrow of time that shapes your experience, something that turns quantum possibilities into classical realities, and it has everything to do with how energy and information flow through the universe around you. Listen to the gentle symphony playing all around you. Your warm tea slowly cooling in its cup, the heat from your body warming the sheets beneath you, the soft sound of your breathing mixing oxygen and carbon dioxide in the air. Each of these moments is a note in the universe's most fundamental melody, a song called entropy. Entropy sounds like a complicated word, but it describes something beautifully simple. It's the tendency of things to spread out, to mix together, to become more evenly distributed throughout space. Like drops of ink swirling through water, energy always flows from places where it's concentrated to places where it's scattered. Think of a handful of marbles in a box. Shake the box once, and the marbles roll around randomly. They never arrange themselves back into the neat pile where you started. Each shake spreads them out more. This spreading, this gentle drift toward randomness, creates the arrow of time that carries you from yesterday into tomorrow. Your coffee cup demonstrates this process perfectly. The hot liquid contains energy packed tightly into fast-moving molecules. The cooler air around the cup has slower, more relaxed molecules. Heat flows naturally from the energetic coffee to the calm air, never the other way around. This one-way flow of energy creates the forward march of time. But here's something wonderful to consider as you rest. The universe is full of examples where this process seems to reverse itself, where order emerges from chaos like flowers blooming from scattered seeds. Every morning, plants around the world perform a miracle. They capture scattered sunlight and use it to build complex sugars from simple carbon dioxide and water. This process, called photosynthesis, creates order from disorder. It's as if the marbles in the box suddenly rolled back into a neat pile all by themselves. Your own body performs similar miracles every second. Your cells take simple nutrients and build complex proteins. Your brain organizes random electrical signals into coherent thoughts. Your heart coordinates billions of cellular activities to maintain its steady rhythm. Life itself seems to swim upstream against entropy's current. How is this possible? The answer lies in understanding that entropy isn't just about one small system like your coffee cup. It's about the entire universe. When plants create order by making sugar, they also create disorder by releasing heat and waste products. The total amount of entropy in the universe still increases, even as local pockets of order bloom like islands in a sea of chaos. Scientists have discovered something remarkable about these islands of order. Under the right conditions, they can become so stable that they resist entropy's pull for very long periods. Some even seem to grow more organized over time, creating complex patterns and structures that persist for millions of years. Your DNA is one such island of order. It contains information that has been passed down through countless generations, resisting the universe's tendency toward randomness. The instructions encoded in your genes represent a victory of information over entropy, a message written in molecules that time has not yet erased. But perhaps the most fascinating discovery is that entropy itself might not be as one-sided as it appears. In very small systems, with just a few particles, scientists have observed what they call entropy fluctuations. These are brief moments when a natural flow reverses, when heat flows from cold to hot, when scattered energy spontaneously concentrates. Imagine watching a movie of cream being stirred into coffee. Normally, you see the cream spread out until the coffee becomes uniformly light brown. But if you could zoom in on just a tiny portion of the cup, you might occasionally see the opposite, small regions where the cream briefly unmixes itself, creating swirls of pure white in the brown liquid. These fluctuations happen constantly at the molecular level. They're usually too small and too brief to notice, but they represent moments when time's arrow wobbles, when the future briefly flows into the past. In laboratories around the world, scientists have learned to create conditions where these fluctuations become large enough to observe and measure. Some researchers have even succeeded in creating tiny heat engines that run backward, pumping heat from cold objects to hot ones using nothing but the random motion of molecules. These devices don't violate any laws of physics. Instead, they demonstrate that those laws are more flexible than we once believed. The mathematics of entropy contain hidden symmetries, equations that work equally well whether time flows forward or backward. This suggests that, at the deepest level, the universe doesn't prefer one direction of time over another. The arrow of time that you experience emerges from the statistical behavior of countless particles, not from any fundamental preference built into reality. Think of it like a vast river made up of billions of water droplets. Each individual droplet moves in random directions, sometimes upstream, sometimes downstream. But the collective motion of all the droplets creates a current that flows consistently in one direction. Your experience of time is like riding on this statistical current. Yet within the river, there are always eddies and backflows, small currents that move against the main stream. These represent the entropy fluctuations, the brief moments when time's arrow points in the opposite direction. In the quantum realm we explored earlier, these fluctuations might be more common and more significant than in your everyday world. As you breathe slowly and feel your body relaxing, you're participating in this cosmic dance between order and disorder. Your lungs organize air molecules, extracting oxygen and releasing carbon dioxide. Your cells burn fuel to maintain their complex structures. Your brain weaves random neural firings into the coherent experience of consciousness. All around you, entropy flows like a gentle tide. Coffee cools, flowers bloom and fade. Stars burn bright and eventually grow dim. Yet within this grand unwinding, pockets of order persist and even grow. Life creates complexity. Consciousness emerges from chaos. Love builds connections that span both space and time. The entropy lullaby is not a song of ending, but of transformation. Energy doesn't disappear, it changes form. Information doesn't vanish, it spreads throughout the cosmos. The universe isn't winding down like a clock. It's evolving into forms of beauty and complexity that no one could have predicted. Tonight, as you drift towards sleep, you join this ancient rhythm. Your body temperature slowly equalizes with the air around you. Your thoughts scatter and recombine in dreams. You become part of the universe's gentle journey from order to chaos and back again. But what drives this endless dance of transformation? What fundamental forces shape the way energy flows and information spreads? To understand time's deeper currents, we must explore the laws that govern heat, motion, and the very fabric of reality itself. Feel the gentle warmth radiating from your skin into the cool air around you. This simple act of cooling follows laws that were discovered by watching steam engines chug along railroad tracks over 2 centuries ago. The same principles that power locomotives also govern the beating of your heart, the burning of distant stars, and the flow of time itself. Long before anyone understood atoms or quantum mechanics, engineers noticed something curious about heat and work. They found that heat always flows from hot objects to cold ones, never the other way around. They discovered that you can turn heat into mechanical work, like steam pushing a piston, but you can never convert work back into heat with perfect efficiency. These observations became the foundation of thermodynamics, the science of heat and energy. The word itself means heat in motion, and it describes the fundamental rules that govern how energy moves through the universe. These rules seemed absolute, as unchangeable as the rising of the sun. The first law of thermodynamics says that energy can neither be created nor destroyed, only transformed from one form to another. The warmth leaving your body doesn't vanish. It becomes motion in the air molecules around you, adding to the invisible dance of particles that fills your bedroom. The second law goes deeper. It declares that in any energy transformation, some useful energy always becomes unavailable for future work. This unavailable energy represents an increase in entropy, the spreading out of energy we explored in our last chapter. Together, these laws seem to paint a picture of a universe slowly running down, like a wind-up toy gradually coming to rest. But as scientists learned to work with smaller and smaller systems, they began to discover exceptions to these seemingly ironclad rules. In a world of individual molecules and tiny machines, the second law becomes more of a gentle suggestion than an absolute command. Imagine watching a single drop of food coloring fall into a glass of water. Normally, you'd see the color spread evenly throughout the liquid, never to unmix again. But if you could watch just a few molecules at a time, you'd occasionally see something remarkable. Small pockets of color would spontaneously concentrate, briefly reversing the mixing process. These molecular rebellions happen because the second law is actually a statistical statement about the behavior of vast numbers of particles. When you're dealing with billions and billions of molecules, the statistics become so overwhelming that exceptions are invisible. But when you focus on just a handful of particles, the exceptions become noticeable and measurable. Scientists have learned to harness these molecular rebellions to create what they call Brownian motors. These are tiny machines that extract useful work from the random motion of molecules in their environment. It's like building a windmill that generates electricity from the chaotic movement of air molecules, even in perfectly still air. Your own cells contain molecular machines that work on similar principles. The proteins that build and repair your body use the random thermal energy around them to fold into complex shapes and perform their functions. They're like microscopic origami masters who use the jittering of surrounding molecules to fold themselves into perfect three-dimensional sculptures. Even more surprisingly, researchers have created heat engines that run backward without requiring any external energy source. These engines pump heat from cold objects to hot ones by cleverly using the natural fluctuations in molecular motion. They don't violate the laws of thermodynamics, but they do demonstrate that those laws are more flexible at small scales than anyone previously imagined. The key insight is that the second law of thermodynamics isn't really about heat or energy at all. It's about information. Every time energy spreads out or becomes unavailable for work, information about the detailed arrangement of particles becomes lost or scattered. The arrow of time emerges from this loss of information, not from any fundamental preference in the laws of physics. Think of it like a library where books occasionally fall off the shelves and land in random piles. Over time, the careful organization of the library degrades into chaos. But if you could track the exact position and motion of every falling book, you could, in principle, reverse the process and restore perfect order. The universe is like this cosmic library with particles instead of books. The second law of thermodynamics describes the statistical tendency for organization to degrade over time. But at the level of individual particles, all the information needed for reversal is still there, encoded in the positions and velocities of every molecule. This realization has led to one of the most profound insights in modern physics. The laws of thermodynamics are not fundamental features of reality. They are emergent properties that arise from our limited perspective as large creatures who can't track the detailed behavior of individual atoms. Maxwell, the great physicist, imagined a tiny demon who could see and control individual molecules. This demon could open and close a small door between two chambers of gas, letting only fast molecules through in one direction and slow molecules in the other. Such a demon could decrease entropy, making heat flow from cold to hot without doing any work. For over a century, physicists debated whether Maxwell's demon was possible. The resolution came from understanding that the demon would need to gather and process information about each molecule. This information processing would itself generate entropy, preserving the second law overall. But the debate revealed something beautiful: the deep connection between thermodynamics, information, and computation. Modern experiments have created real versions of Maxwell's demons using lasers and computer-controlled feedback systems. These devices can indeed make small amounts of heat flow backward, but only by investing energy in the measurement and decision-making process. They demonstrate that the boundary between thermodynamics and information theory is far more porous than early scientists imagined. As you lie quietly in the gathering darkness, your body participates in countless thermodynamic processes. Your cells burn fuel to maintain their organization. Your brain processes information while generating heat. Your heart pumps blood against gravity and friction. Each of these processes follows thermodynamic laws, yet each also represents a local victory over entropy spread. Your very existence is a thermodynamic miracle. The chemical reactions that power your cells, the electrical signals that carry your thoughts, the mechanical work that moves your muscles, all represent highly organized energy transformations. You are a living example of how complex patterns can emerge and persist even in a universe trending toward disorder. The warmth radiating from your skin carries away the entropy generated by your metabolism, allowing your body to maintain its intricate organization. You are not separate from the thermodynamic universe around you. You are one of its most beautiful expressions, a temporary eddy of order in the cosmic flow of energy and information. Tonight, as your body temperature gradually aligns with your surroundings, you participate in the same fundamental processes that govern everything from the smallest molecular machines to the largest stars. The laws of thermodynamics don't just describe steam engines and refrigerators. They describe the conditions that make life, consciousness, and time itself possible. But there's an even deeper layer to this story, one that connects the flow of energy to the flow of information, revealing how the universe might be weaving together the threads of past and future in ways we're only beginning to understand. Every breath you take creates a ripple of information that spreads throughout the universe. The oxygen molecules entering your lungs carry histories written in their atomic structure. They remember the stars where they were forged, the plants that once released them, the countless other lungs they have filled before reaching yours. Information, scientists have discovered, is not just data stored in books or computers. It is a fundamental feature of reality itself, as basic as matter and energy. Every particle in your body contains information about its position, its motion, its relationships with other particles. This information cannot be destroyed, only transformed and redistributed. Think of the universe as an immense library that has been collecting stories for nearly 14 billion years. Every event that has ever occurred, from the collision of galaxies to the flutter of a butterfly's wing, has left its mark in this cosmic archive. The information is stored not in books, but in the positions and movements of particles, in the patterns of waves and fields that fill all of space. Your brain participates in this universal memory system every moment. As you form a thought, neurons fire in specific patterns, creating physical changes that encode information. These changes persist in your neural networks, allowing you to remember experiences from years ago. But the information doesn't stop at the boundaries of your skull. When you speak, sound waves carry information through the air. When you move, you disturb the electromagnetic fields around your body. When you simply exist, your gravitational field subtly influences every other object in the universe. All of these interactions leave permanent traces in the fabric of spacetime itself. The study of information in physics began with a simple question about black holes. These cosmic monsters devour everything that falls into them, including light itself. But what happens to the information contained in the matter that disappears beyond a black hole's event horizon? For decades, physicists debated whether this information could be lost forever. It seemed impossible because all of physics is based on the principle that information is conserved. Every physical process, from the collision of billiard balls to the fusion of hydrogen in stars, preserves information even as it transforms it. Losing information would violate the most fundamental rules of quantum mechanics. The resolution came from understanding that information and entropy are intimately connected. Remember entropy, the tendency of energy to spread out and become less useful. Scientists discovered that entropy is actually a measure of missing information. When heat flows from your coffee to the surrounding air, you lose information about which molecules were originally in the hot coffee and which were in the cool air. This insight revealed something profound about the nature of time and memory. The arrow of time, the reason you remember the past, but not the future, emerges from the loss of information about the detailed arrangements of particles. But if that information could somehow be recovered, time's arrow might reverse direction. Modern quantum physics suggests that the universe operates like a vast quantum computer, processing information through every interaction between particles. Your thoughts, your dreams, your memories are part of this cosmic computation. Every chemical reaction in your cells, every photon of light that touches your skin adds new information to the universal calculation. Some physicists propose that this cosmic computer might be reversible. Just as you can rewind a movie to watch events unfold backward, it might be possible to reverse the universe's computation, recovering all the information that seems to have been lost to entropy. This would effectively turn back the clock, restoring past states from present conditions. The idea sounds like science fiction, but experiments have already demonstrated information reversal on small scales. Scientists have succeeded in reversing the quantum states of individual particles, essentially making them forget changes that had occurred. They've created quantum systems that can be rewound like recordings, playing back their evolution in reverse. Your DNA represents one of nature's most sophisticated information storage systems. The genetic code, written in your cells, contains instructions accumulated over billions of years of evolution. This information has been copied and preserved across countless generations, surviving the death of individual organisms through the miracle of reproduction. But DNA is just one example of how life preserves and transmits information across time. Your immune system maintains a molecular memory of past infections. Your nervous system stores patterns of connections that encode your experiences and skills. Even your bones remember the stresses they have endured, growing stronger in response to repeated loads. The preservation of biological information creates a form of temporal bridge. Through heredity and memory, the past influences the present and shapes the future. Your ancestors live on in your genes. Your experiences become part of the information patterns that define who you are. In this sense, time becomes not a river flowing in one direction, but a web of connections linking past, present, and future. Recent discoveries in quantum biology suggest that living systems might be even more sophisticated information processors than previously imagined. Plants appear to use quantum effects to optimize photosynthesis. Birds might navigate using quantum compass systems in their cells. Your own brain might employ quantum processes to enhance memory and consciousness. If life has learned to harness quantum information processing, it might also have access to the time-reversible properties of quantum mechanics. Your memories might be more than simple recordings of past events. They might be quantum information patterns that connect your present consciousness to your past experiences in ways that transcend ordinary time. The cosmic microwave background radiation that fills all of space carries information from the universe's earliest moments. This ancient light preserves a snapshot of conditions just 380,000 years after the Big Bang. By studying this radiation, astronomers can literally see into the past, reading the universe's memory of its own birth. Every star that has ever shone has left traces of its existence in the light it emitted and the heavy elements it created. These stellar memories drift through space, eventually becoming part of new stars, planets, and living beings. You are made from the memory of long-dead stars, carrying their information forward through time. The electromagnetic radiation from your own body carries information about your current state out into space at the speed of light. This radiation will continue traveling through the cosmos long after you are gone, preserving a permanent record of your existence. In this sense, you are already immortal, your information patterns spreading throughout the universe like ripples on an infinite pond. As you rest in the quiet darkness, imagine yourself as part of this vast information web that connects all things across space and time. Your thoughts contribute to the universe's ongoing computation. Your memories add new entries to reality's infinite library. Your very existence creates permanent changes in the structure of space-time itself. The boundary between your individual consciousness and the cosmic information field might be more porous than it appears. Your dreams might tap into information patterns that extend beyond your personal experience. Your intuitions might access quantum information processing that operates outside the normal flow of time. Scientists are still exploring the deepest implications of information conservation in physics. Some researchers believe that the universe might be holographic, with all the information about its interior encoded on its boundary. Others propose that consciousness itself might be an information processing phenomenon that transcends the usual limitations of space and time. Tonight, as your consciousness gradually fades into sleep, you become part of the universe's dreaming process. Your brain continues processing information, forming new connections, consolidating memories. You participate in the cosmic computation that weaves together past, present, and future into the fabric of reality. But there are places in the universe where this fabric becomes stretched and distorted, where the normal flow of information and time breaks down completely, revealing glimpses of what lies beyond our everyday experience of temporal sequence. Imagine a place so strange that your heartbeat would slow to a crawl while the universe aged millions of years around you, where gravity becomes so intense that it bends the very fabric of space and time like a child twisting modeling clay. These places exist throughout our cosmos, hidden in the darkness between stars. They are called black holes, and they hold secrets about time that would astonish even the greatest poets. Picture yourself floating safely in space, watching a friend drift toward one of these cosmic mysteries. From your distant perspective, something magical and unsettling begins to happen. Your friend's movements become slower and slower, as if they were moving through invisible honey. Their watch appears to tick more and more leisurely until it almost stops completely. This isn't an illusion. Time itself runs slower in stronger gravitational fields. Einstein discovered this truth over a century ago, realizing that space and time are woven together into a single fabric that massive objects can stretch and compress. Near a black hole, this fabric becomes so warped that time stretches like taffy in the cosmic wind. Your friend, however, experiences something completely different. From their perspective, time flows normally. Their watch ticks at its usual pace. Their thoughts move at regular speed. But when they look back at you, they see the entire universe speeding up like a movie played in fast forward. Stars are born and die in what seems like moments. Galaxies spiral through their ancient dances in the blink of an eye. This difference in the experience of time creates one of the most beautiful paradoxes in all of science. Two observers sharing the same universe can have completely different relationships with time depending on where they stand in the gravitational landscape around them. But black holes hide an even deeper mystery about time's nature. At the edge of a black hole lies an invisible boundary called the event horizon. Cross this line, and you can never return to the outside universe. From the perspective of distant observers, anything approaching this boundary appears to slow down and fade away, frozen forever at the moment of crossing. Yet recent discoveries suggest that the story becomes far more complex when we consider quantum mechanics. Stephen Hawking showed that black holes slowly evaporate by emitting radiation, a process so gradual that a black hole with the mass of our sun would take longer than the age of the universe to disappear completely. This Hawking radiation carries away information about everything that ever fell into the black hole. As the black hole shrinks, it must somehow return all that information to the outside universe. But how can information escape from a place where time itself appears to have stopped? Some physicists believe the answer lies in understanding that the event horizon isn't as solid as it appears. From the outside, you see objects frozen at the boundary, but the black hole's interior continues evolving. The information about fallen objects might be encoded on the event horizon itself, like a cosmic hologram that preserves every detail of what disappeared inside. Others propose that the interior of a black hole connects to distant regions of space and time through shortcuts called wormholes. These cosmic tunnels might allow information, and possibly even matter, to emerge in unexpected places and times. A black hole in your galaxy might connect to a white hole in another galaxy, or even in another era of cosmic history. The mathematics describing black holes contain beautiful symmetries that suggest time reversal is not only possible, but inevitable in these extreme environments. The equations work equally well whether time flows forward or backward. This mathematical democracy hints that black holes might be places where the universe experiments with running time in both directions simultaneously. Near the center of a black hole, where density becomes infinite and the laws of physics break down, space and time might become so twisted that past and future lose their meaning entirely. Some researchers speculate that these cosmic hearts might be where the universe processes information about its own history, perhaps even determining which possible timelines become real. Your own galaxy harbors a supermassive black hole at its center, millions of times more massive than our sun. This cosmic giant helps hold our spiral of stars together, its gravity orchestrating the slow dance of billions of suns across hundreds of millions of years. You orbit this distant monster as surely as you orbit the sun, though at a much greater distance and with a period measured in hundreds of millions of years. Even from this vast distance, that central black hole influences your experience of time. The gravitational field it creates contributes to the overall curvature of spacetime in your cosmic neighborhood. Your clocks run slightly differently than they would in the emptier regions between galaxies, though the difference is far too small for you to notice. But the influence goes deeper than just the ticking of clocks. The black hole at our galaxy's heart has shaped the evolution of stars and planets throughout cosmic history. By controlling how gas and dust flow through the galaxy, it has influenced which stars form and where. In a very real sense, that distant black hole helped create the conditions that allowed your sun, your planet, and ultimately you to exist. Black holes also serve as cosmic time capsules, preserving information about the early universe in ways we're only beginning to understand. The oldest black holes formed when the universe was young and very different from today. They carry memories of that ancient era encoded in their spin, their mass, and the subtle patterns of radiation they emit. As you rest in the gentle darkness of your bedroom, you exist in a universe where black holes whisper secrets about time's deepest nature. These cosmic laboratories stretch and compress temporal experience, creating natural experiments that reveal truths about reality no earthbound laboratory could discover. The presence of black holes throughout the cosmos means that time flows differently in countless locations across the universe. There is no universal now that applies everywhere. Instead, time fractures into a symphony of different tempos, each region of space keeping its own rhythm in the cosmic orchestra. This fragmentation of time opens possibilities that seem to come from dreams rather than physics. Information might flow not just through space, but through time itself, creating connections between distant eras that transcend the simple sequence of cause and effect. Yet even as black holes reveal time's malleability, they also hint at deeper mysteries about how the universe decides which of many possible timelines becomes real, and whether the quantum realm holds keys to understanding time's most fundamental secrets. In the quiet corners of research laboratories around the world, scientists have built stages for the most extraordinary performances in the universe. Here, under conditions colder than outer space and more isolated than the depths of the ocean, quantum particles perform acts that seem to defy everything you know about time and causality. Picture a theater where the actors know their lines before the playwright has written them, where the final scene influences the opening act, where the audience's decision to watch or look away changes the entire play. This is the quantum theater, and you are both audience and participant in its mysterious performances. The stage is set with apparatus so delicate that a whisper could disturb the show. Lasers create beams of light pure enough to carry single photons. Mirrors polish to perfection reflect these lonely particles along carefully planned paths. Detectors sensitive enough to register the arrival of individual quantum actors wait patiently in the wings. In this theater, scientists have discovered that particles can exist in what they call superposition, simultaneously playing multiple roles until the moment of measurement forces them to choose just one. It's as if an actor could be the hero, the villain, and the comic relief all at once, only becoming a single character when the curtain rises and the audience looks. But the most astonishing discovery is that the moment of measurement, the act of observation itself, seems to reach backward through time to influence what the particle was doing before anyone decided to look. The future, in a sense, helps write the past. Consider one of the most elegant experiments in all of science, the delayed choice quantum eraser. Scientists send individual photons through a maze of mirrors and beam splitters. Along the way, the photons encounter devices that could potentially reveal which path each particle took. But here's the key. The scientists can choose whether to actually look at this path information long after the photon has already traveled through the maze. What they discovered defies common sense. If they choose to erase the path information after the photon has completed its journey, the particle behaves as if it traveled along all possible paths simultaneously. If they choose to keep the information, the photon behaves as if it took only one definite path, even though this choice was made after the journey was complete. The photon seems to know, somehow, what the experimenters will decide to do in the future. The measurement that hasn't happened yet influences the behavior that has already occurred. Time's arrow, so reliable in your everyday experience, begins to wobble and point in unexpected directions. You might wonder if this strangeness stays locked in the laboratory, isolated from the world of flowers and coffee cups and sleeping cats. But the boundary between the quantum realm and your familiar reality is more porous than it appears. Every moment, quantum processes in your eyes capture photons and convert them to electrical signals. Your brain processes these signals through neural networks that might themselves involve quantum effects. Some scientists propose that consciousness itself emerges from quantum processes in the microscopic structures of your brain cells. If this is true, then your awareness might participate directly in the quantum theater. Your thoughts might influence the collapse of quantum superpositions. Your decisions might reach backward through time to shape the quantum events that preceded them. This possibility opens profound questions about free will and the nature of choice. If quantum mechanics allows the future to influence the past, then your decision to think a particular thought might retroactively create the quantum brain states that made that thought possible. You might be participating in a cosmic feedback loop where consciousness and physical reality continuously reshape each other across the boundaries of time. The quantum theater also features a phenomenon called entanglement, where particles become connected in ways that transcend ordinary space and time. When two particles become entangled, measuring one instantly affects the other, regardless of the distance between them. Einstein found this so troubling that he called it spooky action at a distance. But recent experiments have revealed something even more spooky. Quantum entanglement can exist across time as well as space. Particles can become entangled with their own future and past states, creating connections that link different moments in a single quantum system's history. The present becomes entangled with its own tomorrow and yesterday. Imagine a conversation where your words today influence something your friend said yesterday, and their past words shape what you will say tomorrow. This temporal entanglement means that the quantum world doesn't just allow communication faster than light across space. It allows communication across time itself. In your body, quantum effects play out in countless biological processes every second. The proteins that build and maintain your cells rely on quantum tunneling to fold into their proper shapes. The enzymes that power your metabolism use quantum coherence to find the most efficient reaction pathways. Your DNA itself might use quantum effects to maintain its structural integrity and facilitate accurate replication. Some researchers believe that evolution has learned to harness quantum mechanics for biological advantage. Birds might navigate using quantum compass systems that exploit entanglement between electron spins. Plants might optimize photosynthesis through quantum coherence effects that allow energy to explore all possible pathways simultaneously before choosing the most efficient route. If life has indeed learned to surf quantum waves, then biological systems might have access to the time-symmetric properties of quantum mechanics. Your memories might be quantum information patterns that create connections across time. Your intuitions might tap into quantum superpositions of possible futures. Your dreams might explore quantum realities where the usual rules of causation don't apply. The quantum theater never truly ends. Even as you rest quietly in your bed, quantum actors continue their performances throughout your body and the world around you. Electrons tunnel through biological barriers they shouldn't be able to cross. Photons maintain coherent superpositions across the molecular machinery of your cells. Quantum fields fluctuate in the empty space between the atoms that make up your being. These quantum performances create a reality far richer and more interconnected than it appears on the surface. The solid matter of your body emerges from quantum fields that fill all of space. The thoughts in your mind might arise from quantum computations that explore multiple possibilities simultaneously. The flow of time itself might be a macroscopic effect that emerges from the timeless dance of quantum interactions. Modern technology increasingly depends on harnessing quantum effects. The computer processors that power your devices rely on quantum tunneling. The GPS satellites that guide navigation systems must account for quantum effects in their precise timekeeping. Researchers are developing quantum computers that could solve problems impossible for classical machines by exploring all possible solutions in quantum superposition. As quantum technology advances, we might gain new tools for exploring the relationship between consciousness, time, and reality. Quantum computers might simulate biological quantum processes, revealing how life uses quantum mechanics. Quantum sensors might detect the subtle quantum effects in living brains, illuminating the quantum nature of thought and awareness. The quantum theater suggests that reality operates more like an improvised performance than a scripted play. Actors influence each other across space and time, creating a story that emerges from their interactions rather than following a predetermined plot. You are one of these actors, connected to every other performer through invisible quantum threads that span the cosmos. Tonight, as your consciousness fades into sleep, you remain connected to this vast quantum performance. Your brain continues processing information through networks that might exploit quantum effects. Your dreams might explore quantum superpositions of memory and imagination, past and future, reality and possibility. But to understand how these quantum mysteries might allow for actual time reversal, we must explore the deepest architectural principles that govern how causes create effects, and how that architecture might be more flexible than we ever imagined. Think of your life as a beautiful tapestry woven from countless threads of cause and effect. You wake up because your alarm clock rings. You feel hungry because your body needs fuel. You smile because something brings you joy. Each thread connects one moment to the next, creating the fabric of your experience through time. But what if these threads could be rewoven? What if the pattern of cause and effect that seems so natural and unchangeable could actually be rearranged, allowing effects to precede their causes, or even to reach backward and create the very conditions that made them possible? The architecture of causality, the fundamental structure that determines how events influence each other, might be far more flexible than you imagine. In your everyday world, causes always seem to come before effects. You drop a stone, and then it falls. You flip a switch, and then the light turns on. This sequence feels as natural as breathing. Yet scientists have discovered that the deepest laws of physics show no preference for this temporal order. The equations that describe how particles interact, how forces operate, how energy flows, work equally well whether time moves forward or backward. The mathematical foundation of reality treats past and future with perfect democracy. This symmetry in the laws of nature suggests that the arrow of time you experience is not built into the fundamental structure of the universe. Instead, it emerges from something more subtle, more statistical, more dependent on perspective and scale than anyone once imagined. Consider the simple act of lighting a candle. You strike a match, the flame appears, you touch it to the wick, and the candle begins to burn. This chain of cause and effect seems obvious and inevitable. But at the level of individual atoms and molecules, the story becomes more complex and mysterious. The chemical reaction that creates the flame involves countless molecular collisions, each one governed by quantum mechanical principles. At this microscopic scale, every collision is actually time reversible. The same laws that allow molecules to combine and release energy also allow them, in principle, to absorb energy and separate back into their original forms. The candle burns forward in time only because of statistics. There are far more ways for the molecules to be scattered and the energy to be spread out than there are for them to be concentrated in the organized form of wax and oxygen. The flame represents a journey from a less probable state to a more probable one, like water flowing downhill. But in very small systems, with just a few molecules, these probabilities can shift. Scientists have created molecular machines that operate in reverse, using thermal energy from their surroundings to perform work, essentially running backward compared to ordinary heat engines. They've observed chemical reactions that spontaneously reverse themselves, returning products to their original reactant forms. These microscopic reversals hint at a deeper truth about causality. The relationship between cause and effect might be more like a conversation than a one-way command. In quantum mechanics, the act of measurement not only reveals the state of a particle, but actually participates in creating that state. The observer becomes part of the causal chain, blurring the line between cause and effect. Your consciousness participates in this causal architecture every moment. When you decide to move your hand, neural signals travel from your brain to your muscles. But recent research suggests that your brain begins preparing for this movement before you become consciously aware of your decision to move. The effect, your conscious intention, might actually follow the cause, the unconscious neural preparation. This discovery raises profound questions about the nature of free will and decision-making. If your brain begins acting before you consciously decide, who or what is really making your choices? Some neuroscientists propose that consciousness doesn't create decisions, but rather becomes aware of decisions that have already been made by unconscious processes. But quantum mechanics offers another perspective. If quantum effects play a role in brain function, then the relationship between your conscious thoughts and your brain states might involve the same kind of temporal flexibility we see in quantum experiments. Your awareness might participate in a feedback loop with your neural processes, each influencing the other across time in ways that transcend simple cause and effect. The structure of spacetime itself might support these causal loops. Einstein's theory of relativity allows for closed time-like curves, paths through spacetime that curve back to their own starting points. While such exotic geometries might require extreme conditions involving black holes or cosmic strings, they demonstrate that the universe's architecture doesn't forbid causal loops in principle. Some physicists have proposed that quantum mechanics and general relativity might combine to create natural time loops at the smallest scales. Virtual particles that constantly appear and disappear in the quantum vacuum might occasionally loop back through time, creating microscopic closed causal chains that influence the macroscopic world in subtle ways. Your very existence demonstrates the power of causal loops operating across cosmic timescales. The heavy elements in your body were forged in the cores of ancient stars. Those stars formed from clouds of gas and dust shaped by the gravitational influence of dark matter. The patterns of dark matter were established by quantum fluctuations in the early universe. In a sense, quantum events billions of years ago helped create the conditions for your thoughts today. But the loop extends further. Your consciousness, arising from quantum processes in your brain, participates in the ongoing quantum measurement and collapse of wave functions throughout the universe. Your observations, your choices, your very awareness contributes to the unfolding of quantum reality. You are not just a product of cosmic evolution. You are an active participant in its continuation. This participatory universe suggests that causality might be more like a web than a chain. Events influence each other across space and time through networks of connection that can loop back on themselves. The future might influence the past, not through dramatic time travel scenarios, but through subtle quantum effects that operate continuously at the foundation of reality. As you rest quietly tonight, feel yourself embedded in this vast web of causality. Your breathing influences the air around you, which carries information about your presence to distant places. Your thoughts create neural patterns that emit electromagnetic fields, contributing to the planet's overall electromagnetic signature. Your dreams might tap into quantum processes that connect your sleeping mind to the larger patterns of cosmic evolution. The architecture of causality that supports your existence is both ancient and constantly renewed. The same quantum fields that gave birth to the first atoms continue to fluctuate around you. The same forces that shaped the earliest stars continue to operate in your cells. You are not separate from this cosmic architecture. You are one of its most beautiful expressions. But if causality is indeed more flexible than it appears, if the universe's fundamental architecture allows for loops and reversals and conversations between past and future, then what would this mean for the practical possibility of actually reversing time's flow? In laboratories scattered across the world, scientists have begun to witness something that sounds like magic, but emerges from the most rigorous application of physical law. They have learned to make time run backward, at least for tiny systems lasting microseconds. These reversible revelations offer glimpses into a universe far more flexible than the one you experience in your daily life. The journey toward time reversal began with understanding that the fundamental equations of physics are time-symmetric. Whether you solve them moving forward through time or backward, the mathematics works equally well. It's like discovering that a beautiful piece of music sounds just as harmonious when played in reverse, note by note, as when played in its original direction. Your intuition rebels against this idea because your everyday experience shows you a world where broken glasses don't spontaneously reassemble, where mixed coffee and cream never separate, where aged faces don't grow young again. Yet these irreversible changes result from statistics and probability, not from any fundamental law that forbids reversal. Think of a movie showing a diver jumping into a perfectly still pool. Played forward, You see the person leap from the board, slice through the air, and create a splash as they enter the water. Played backward, you see water suddenly organize itself into a perfect human shape that launches upward, lands gracefully on the diving board, and walks away. Both sequences follow the laws of physics perfectly. Only our experience tells us which direction seems natural. Scientists have created real-world versions of this reversed movie, though on scales so small that you need sophisticated instruments to observe them. They've made individual particles retrace their paths through space. They've caused quantum systems to evolve backward in time, undoing changes that had already occurred. One of the most elegant demonstrations involves nuclear magnetic resonance, the same technology that creates images inside your body during medical scans. Researchers can manipulate the magnetic properties of atomic nuclei, causing them to evolve forward in time toward a more disordered state, then applying carefully crafted magnetic pulses that reverse this evolution, returning the system to its original order condition. It's as if they've learned to conduct an orchestra of atomic musicians, first allowing the music to become chaotic and discordant, then waving a magic wand that causes every note to retrace its path until the original harmony is restored. The atoms don't just return to a similar state. They return to exactly the same quantum state they started from. These time reversal experiments work because researchers can control every aspect of the quantum system's environment. They isolate their atomic performers from outside interference, creating a pristine stage where quantum evolution can unfold according to its fundamental time-symmetric laws without the complications that create irreversibility in larger systems. But the implications reach far beyond laboratory demonstrations. If time reversal is possible for small systems, what prevents it from occurring in larger ones? The answer lies in the practical impossibility of controlling every particle in a macroscopic object. Your coffee cup contains trillions of molecules, each one interacting with countless others and with the environment around them. To reverse the cooling of your coffee, you would need to precisely control the motion of every single molecule, knowing exactly where each one is and how fast it's moving at every instant. You would need to orchestrate their interactions with perfect precision, like conducting a symphony with more musicians than there are stars in the observable universe. Yet the theoretical possibility remains. If you possessed infinite knowledge and control, you could reverse any physical process, no matter how complex. You could make the cream separate from the coffee, make the broken glass reassemble, even reverse the biological processes of aging. The universe's fundamental laws don't forbid these reversals. They merely make them astronomically improbable. This realization has profound implications for how you understand your place in the cosmic story. Every breath you take, every thought you think, every choice you make becomes part of an enormous quantum system that includes the entire universe. In principle, all of this information remains preserved in the detailed state of every particle and field. Some physicists speculate that advanced civilizations might develop the ability to harness quantum information processing on cosmic scales. They might learn to reverse large-scale processes, to undo catastrophes, to restore damaged ecosystems, or even extinct species by running the universe's quantum state backward to earlier configurations. Your own body demonstrates nature's remarkable ability to maintain order and even reverse damage on biological scales. Your cells continuously repair DNA damage, rebuild worn-out proteins, and replace aging tissues. Your immune system learns from past infections and develops better responses for the future. Your brain forms new connections that can compensate for damaged regions. These biological reversals don't violate thermodynamics because they occur in open systems that exchange energy and matter with their surroundings. Your body imports low-entropy energy in the form of food and sunlight, uses it to maintain and repair your complex structures, then exports high-entropy waste products. You're a living example of how local time reversal can occur within the larger flow of cosmic entropy. As you rest tonight, quantum processes throughout your body continue this dance of renewal and repair. Molecular machines repair microscopic damage to your cells. Your brain consolidates memories and forms new neural connections. Your entire organism works to reverse the small accumulations of disorder that occurred during your waking hours. Your dreams might represent another form of time reversal, where your sleeping mind processes the day's experiences, sometimes running them backward, rearranging them, finding new patterns and connections that were hidden during waking consciousness. In dreams, cause and effect become fluid, past and future blend together, and your mind explores possibilities unconstrained by the linear flow of time. The quantum fields that make up your body extend throughout all of space, connecting you to every other particle in the universe through subtle but permanent quantum correlations. These connections mean that you are not truly separate from the cosmos around you. You are part of a vast, interconnected quantum system that includes everything that has ever existed. In this quantum view of reality, your consciousness becomes part of the universe's ongoing process of observation and measurement. Your awareness participates in the collapse of quantum wave functions, helping to determine which of many possible futures becomes real. You are not just witnessing the universe's evolution. You are participating in its creation. The reversible revelations of modern physics suggest that the future you help create might not be as fixed as it appears. If quantum mechanics allows for time reversal, then perhaps consciousness, which seems intimately connected to quantum measurement, might also participate in processes that transcend the ordinary flow of time. But to understand how these abstract possibilities might manifest in the material world, we must explore the remarkable substances and systems where scientists have discovered the most dramatic examples of reversible processes, materials that seem to remember their past and can be coaxed to return to it. In research laboratories around the world, scientists work with materials that seem to possess their own memories. These remarkable substances can be bent, twisted, heated, and reshaped. Yet when given the proper signal, they return to their original form as if remembering a distant dream. They offer tangible proof that matter itself can reverse the flow of time, at least on small scales. Picture a paper clip that you straighten completely, then gently warm with your breath. Before your eyes, the metal wire slowly curves and bends, reforming itself back into the familiar clip shape. This isn't magic. It's the behavior of shape memory alloys, materials whose atomic structure can store information about their past configurations like a molecular photograph. The secret lies in how atoms arrange themselves within these special metals. At one temperature, the atoms prefer one arrangement. At another temperature, they prefer a different arrangement. The transition between these arrangements can be programmed to occur at specific temperatures, creating materials that remember their history and can return to it when conditions are right. Your own body contains countless examples of similar memory effects. The collagen fibers in your skin remember their original length and elasticity, allowing your skin to stretch when you smile and then return to its resting state. The proteins in your muscles remember their contracted and relaxed positions, enabling them to work over millions of cycles without losing their ability to return to their original shape. Even your DNA demonstrates this temporal flexibility. When your cells divide, the double helix unwinds completely, separating into two single strands. Yet each strand contains the information needed to rebuild its missing partner, effectively remembering the structure that existed before the separation. The new DNA molecules that form are identical to the original, as if time had reversed to bring back exactly what was there before. Scientists have discovered materials that take this memory effect to extraordinary lengths. Some polymers can remember not just one previous shape, but multiple shapes in sequence. They can be programmed to unfold through a series of transformations, like flowers opening their petals in reverse time-lapse photography, eventually returning to their starting configuration. These materials work by storing energy in their molecular structure, like winding up a spring. The energy remains trapped until the right conditions release it, allowing the material to snap back to its remembered form. In a sense, these substances carry potential energy that reaches across time, connecting their present state to their past. Researchers have created liquid crystals that can reverse their optical properties on command, switching from transparent to opaque and back again. They've developed gels that can remember their original stiffness, even after being made completely soft. They've engineered ceramics that can heal their own cracks by returning to their original atomic arrangements. The most remarkable examples come from the world of biological materials. Scientists studying certain plants have found fibers that can contract and expand with changes in humidity, creating motion that seems to reverse the plant's previous deformation. Some tree leaves curl in dry conditions and uncurl when moisture returns, performing the same movement in reverse like a slow-motion movie running backward. Your muscles operate on similar principles, though much more complex ones. Each muscle fiber contains molecular machines that use chemical energy to create mechanical motion. These machines can operate in reverse under certain conditions, absorbing mechanical energy and producing chemical energy, essentially running backward through their normal cycle. In laboratory settings, scientists have learned to create time-reversed chemical reactions using carefully controlled conditions. They can make products spontaneously separate back into their original reactants, like watching a burned log reconstitute itself from ash and smoke. These reversals require precise control of temperature, pressure, and concentration, but they demonstrate that even chemical transformations can flow backward through time. The key insight from all these discoveries is that reversibility depends on information preservation. Materials that can remember their past shapes do so because their atomic structure retains information about previous configurations. When this information is preserved and the right conditions are provided, the material can use this memory to retrace its transformational steps. Your nervous system employs similar principles on a much grander scale. Your brain stores information about past experiences in patterns of neural connections. When you remember something, your brain doesn't just retrieve a static recording. It partially recreates the neural activity that occurred during the original experience. In a very real sense, remembering involves reversing time in your neural networks. Some researchers believe that consciousness itself might involve time reversal processes. When you recognize a familiar face, your brain might be running pattern-matching algorithms that involve comparing current visual input to stored templates. This comparison process might involve quantum computations that explore multiple possible matches simultaneously, including some that involve time-symmetric operations. The materials in your body are constantly performing molecular time reversals. Enzymes facilitate chemical reactions that can run in either direction depending on the concentrations of reactants and products. Your cells contain molecular motors that can run forward or backward depending on the chemical signals they receive. Even your heartbeat involves cycles of contraction and relaxation that demonstrate sophisticated temporal coordination. Scientists are now developing materials that can remember multiple time points, creating substances that can return not just to their original state, but to any of several intermediate states they've experienced. These materials are like having a personal time machine for objects, allowing them to revisit any point in their transformation history. The implications extend beyond material science. If matter can be programmed to remember and return to past states, then perhaps more complex systems could eventually be designed with similar capabilities. Researchers dream of creating buildings that can repair earthquake damage by returning to their original architectural configurations, or medical implants that can reverse wear and return to their newly installed condition. Your body already demonstrates many of these principles. Your bones can remodel themselves in response to stress, effectively remembering the loads they've experienced and adapting their structure accordingly. Your immune system remembers past infections and can mount faster responses when the same pathogens return. Your skin can heal wounds by regenerating tissue that closely matches what was there before. As you rest tonight, feel the gentle processes of renewal and memory operating throughout your body. Your cells are repairing damage accumulated during the day, using stored information to return proteins and structures to their optimal configurations. Your brain is consolidating memories, strengthening the neural pathways that preserve your experiences. The boundary between your individual existence and the materials that compose you becomes fluid in this context. You are not separate from these memory-holding substances. You are a living example of their most sophisticated expression. Your consciousness emerges from matter that remembers, materials that can reverse their transformations, substances that carry information across time. The laboratory of liquid time exists not just in research facilities, but within your own being. Every cell in your body participates in processes that demonstrate matter's ability to remember and return, to carry information from past to present, and perhaps from present to past. But as our journey through time's mysteries draws toward its close, we must ask, what does all this mean for you as a conscious being suspended between the vast cosmos above and the quantum realm below, carrying within yourself the memory of stars and the possibility of futures yet to be? Our journey through time's deepest mysteries draws to a gentle close, like a river returning to the sea. You have traveled from the familiar flow of everyday moments to the strange shores where quantum mechanics meets consciousness, where black holes whisper backwards, and where the very atoms in your body remember their cosmic history. Rest now in the knowledge that you are far more than you imagined when this night began. You are not just a passenger on time's river, carried helplessly from past to future. You are an active participant in the universe's ongoing creation, a conscious being whose very awareness helps determine which of many possible realities becomes real. The air you breathe carries stories written in the quantum signatures of oxygen molecules. Each breath connects you to the photosynthesis of plants, the fusion fires of stars, and the quantum processes that govern life itself. Your lungs don't just extract oxygen. They participate in the cosmic dance of matter and energy that has been unfolding for billions of years. Your heartbeat keeps time with rhythms that span from the smallest atomic vibrations to the largest galactic rotations. The steady pulse in your chest synchronizes with quantum oscillations in your cells, with the orbital periods of planets, with the slow breathing of the galaxy itself as it turns through space. You are a timekeeper in the universe's vast orchestra. The thoughts flowing through your mind emerge from quantum processes that may transcend the ordinary boundaries of past and future. Your memories might be more than simple recordings. They could be quantum information patterns that create bridges across time, connecting your present consciousness to experiences that shaped who you are and to possibilities that will shape who you might become. In the darkness around you, entropy flows like a gentle tide, but you have learned that this flow is not the enemy of order and complexity. Instead, it creates the conditions that make life, consciousness, and beauty possible. The same statistical processes that make your coffee cool also allow stars to shine, plants to grow, and thoughts to emerge from the quantum realm. Your body demonstrates time's deepest mysteries in every cell. DNA molecules unwind and rewind, carrying information across generations like messages in bottles thrown into time's ocean. Proteins fold and unfold in quantum tunneling events that seem to borrow energy from the future and repay it in the past. Your immune system remembers infections and prepares for encounters that haven't happened yet. The boundary between your individual existence and the cosmic processes around you becomes beautifully blurred in this new understanding. The heavy elements in your bones were forged in stellar cores billions of years ago. The energy flowing through your neurons comes from fusion reactions happening now in the sun's interior. The quantum fields that make up your very being extend throughout all of space and time. You are not separate from the universe's exploration of its own possibilities. Your consciousness participates in the quantum measurement processes that help determine which potential futures become real. Every choice you make, every observation you perform, every dream you dream contributes to the ongoing creation of reality itself. The scientists whose discoveries we've shared see farther into time's mysteries with each passing year. They've learned to make particles dance backward through cause and effect. They've discovered materials that remember their past and can return to it. They've found that black holes might be cosmic archives preserving information about everything that has ever existed. But perhaps most remarkably, They've revealed that the fundamental laws of physics make no distinction between past and future. The mathematical equations that describe everything from quantum mechanics to general relativity work equally well in both directions of time. The arrow of time that guides your experience emerges from complexity and consciousness, not from any basic preference built into reality's foundation. This means that time's river might indeed be more flexible than it appears. While you may never step into the same moment twice in your macroscopic experience, the quantum realm beneath that experience operates according to principles that are beautifully symmetric in time. The future influences the past as surely as the past influences the future, though usually in ways too subtle for everyday awareness to detect. Your dreams tonight might carry hints of this temporal symmetry. In the landscapes of sleep, cause and effect become fluid. Past and future blend into experiences that transcend ordinary sequence. Your dreaming mind explores possibilities unconstrained by the linear flow of waking time, perhaps accessing quantum processing modes that operate outside temporal boundaries. As your consciousness fades into sleep, you join the universe's own dreaming process. The quantum fields that compose your being continue their eternal fluctuations, connecting you to every other pattern of matter and energy across space and time. You become part of the cosmic computation that weaves together all possible histories into the single timeline of experience reality. The gentle tide of entropy that flows around you carries away the day's accumulated disorder while preserving the essential information patterns that make you who you are. Your cells repair themselves using quantum processes that seem to defy time's forward march. Your brain consolidates memories and forms new connections that will shape tomorrow's thoughts and choices. You rest now at the intersection of the very large and the very small, carrying within yourself the memory of stars and the quantum seeds of futures yet to be born. You are a temporary gathering of atoms that has learned to contemplate its own existence, a pattern of information that has become aware of the cosmic processes that created it. The universe dreams through your sleeping mind tonight, exploring possibilities that span from the quantum realm to the cosmic horizon. In your rest, you become a bridge between what was and what might be, a conscious participant in time's most beautiful mystery. Sleep now, knowing that you are far more than a simple traveler through time. You are time's own exploration of what it means to be conscious, to remember, to dream of tomorrow while carrying yesterday's gifts. You are the universe's way of understanding itself, a living question mark in the cosmic sentence that is still being written. Sweet dreams, citizen of a cosmos where time itself might one day learn to flow in the direction of your deepest hopes and highest aspirations.